Okay, so welcome back. Now, in this example, I graphed a couple of functions. Notice that these are pretty much the exact same function, except this g of x is the negative of f of x. Okay, so notice how all the signs are opposite. Okay, but the coefficients are the same. So I'm doing this because I want to show that if you look at the first term, this is positive 2, and if you notice for positive 2, the graph opens out, right? It opens up downward, right? And we have a maximum point. The vertex is at 2, 2. And for g of x, which again is just the opposite of f of x, the leading coefficient here is negative 2. And so we have a vertex at 2, negative 2. But notice that this is negative. And so the graph of g of x opens upward with a minimum point for the vertex. So the vertex represents the minimum point here. So what are we showing? Is to show you that by knowing the values of a, b, and c, we can determine certain things. Okay. One is we could know that how the graph behaves. So if we look at this, we can see that as long as we know a couple of points, 3 points, we can graph the parabola. Okay, so again, here we know the x-intercepts, right, and the vertex. So if we know those 3 points, if we know the x-vertex, the x-intercepts, if they exist, they will not always exist, but if we know 3 points, we can graph, including the vertex, we can graph this function. So if we know the intercepts, including the y-intercept, okay, we could have a y-intercept as well, and usually always do. Okay, may not always have x-intercepts, but we'll have a y-intercept, okay, for these functions. So for example, the y-intercept here is 0, 6, and the vertex for this one is at 0, negative 6. Okay, so if we know a few points, we can graph these very easily, including the vertex. So how do we find the vertex? Well, it comes to find that there's an easy way to find the vertex. So let me show you how we derive this. And there's the formula for the vertex of a parabola. And so what we do is we take the general form, and we set it equal to 0. Well, in this case, we'll just use the function, or the y equals. Okay? And so what we're going to do is we're going to factor out a. So this is similar to what we do when we complete the square, which we are going to do. Okay? So what I'm going to do is I'm going to group these x's together because I'm going to complete the square on this part. So I'm going to leave c alone and kind of ignore it for a moment. Okay? So what I'm going to do is I'm going to group these together. I'm going to factor out the a, because if I'm going to complete the square, I've got to have a leading coefficient of 1. So what I'm going to do is I'm going to factor out the a, and that gives me a squared plus b over a x. This shouldn't be squared. Plus c. Okay, so all I did was factor out the a. Okay, now, what I'm going to do now is complete the square with this one. So I'm going to have to divide the middle term by 2 and square it to do that. So if I do that, I get a times x squared plus bax plus what? I get b squared over 4a squared. because all I did was I divided the middle term by 2, which gives me b over 2a, and then I squared it, okay? But then what happens? I have to add. Right? So I have to add, I'm adding this, right? So I've got the plus c, right? So now what I'm going to do is I'm going to break this apart, but I'm going to distribute the a. So watch what I'm going to do. So this is going to be a times, so I'm going to break this piece off. So I'm going to basically, I'm using the distributive property for this piece and this piece. So I'm kind of separating it out. So a squared, or x squared plus b over ax, right? Oh, actually, let me do this. Minus. That's what I wanted. Okay, so again, the reason why I'm doing this is because I can't just add any number here willy-nilly, right? I've got to keep the equation balanced, meaning I can't add something to the function or to the equation without subtracting it back off so that the net effect is 0, especially if I'm working on the same side, which in this case I'm working on the same side of the equation. So the net effect on one side of the equation has to be 0. So whatever I add, I must also subtract. Okay. So then what I'm going to do is I'm going to use the distributive property to split these two off. That's what I meant to say. Okay. So now this goes like this, and then I'm going to have subtract a minus b squared over 4a squared plus c. Okay, so now this piece is off by itself, and now I get a, this is the perfect square, right? That's the whole purpose of why I was doing this, is to get the perfect square. So this becomes x plus b over 2a quantity squared minus, now this just becomes b squared over 4a plus c, okay? So now notice the piece on the left. Okay? Now, notice that if x equals, right? So what happens for this piece right here? If x equals negative b over 2a, then this whole term goes to 0. Okay? If x is any other term, any other value, I should say, it's positive. So that means if a is positive, so again, so if x is this term goes to 0. If x is any other value, this whole thing is positive, obviously because of the square. So that means if a is positive, then this thing is going to open upward. If a is negative, this thing's going to open downward. Okay? What else can I say about this? So this actually, so the thing that I want to say now is this value, this formula, is the formula for the x-coordinate of the vertex, okay? Because again, this is where this thing goes to 0, okay? Which tells us that everything is increasing, right? So for any other value, if a is positive, right? So let's say a is positive. If x is any other value than this, then what's happening? This thing is increasing, right? Y is increasing from this point for any other value of x, which means that at this point, at x equals negative b over 2a, this is a minimum value. So it's the vertex, right? And likewise, if a is negative and x is anything other than this, then what's happening is this value here is decreasing as for any other value of x. So it's decreasing from a maximum point. So this formula is the formula that we use for finding the x-coordinate of the vertex. And then of course, once we find the x-coordinate, then we just plug that value into the function and find the y-coordinate to find the vertex, the point. Okay? Now another easily found point is the y-intercept. Okay? So notice that if the y-intercept happens when x is equal to 0. So notice when x is equal to 0, all the terms fall out except for the constant term. So we know that for the y-intercept, it's always going to be 0, comma c, where c is the coefficient. That's why I know that the y-intercept for g of x is negative 6, right, or positive 6. Oh, I got these backwards. I'm sorry, when I was drawing them, I got these backwards. This should be, yeah, this should be f of x, or g of x. Or you know what? Let me mix these up. There we go. No. Keep putting it back. This is, hold on. Let's do it this way. There we go. Okay, now I got it fixed. Okay, so notice that c here, the constant term, is negative 6, so that's why I knew that the y-intercept here was going to be negative 6, and the y-intercept here was going to be positive 6 by looking at this constant term. Okay, so 0, comma c is always going to be the y-intercept for a parabola. Okay. So x equals negative b over 2a, that's going to give us the x-coordinate for the vertex, and then we can plug this value back into our function to find the y value, and then we've got the point, the vertex. We can find the y-intercept. Now the x-intercept, we can find x-intercepts, if they exist, we can find by using the quadratic formula or factoring, all the things that we've talked about before. Okay, but let's Again, let's stop here and I'm going to come back and do an example and we'll move forward. Okay? Have a great day.